I would like to draw your attention to some scenarios concerning the utilization of paddy in terms of co-firing. So first, what you can see here is, according to different authors, according to different literature sources, we have considered different amounts of available paddy residues in millions of tons. Some authors give that it's 12 tons, million tons. Some authors say that it's 20 million of tons. Of course, it's all concerning the Punjab state. So that's what we have found. And of course, for the further analysis, we should take, let's say, one number which is somewhere in the middle. So we took these 15 million of tons of available paddy residues, and this coefficient of 50% of percentage of paddy residues burned by the farmers. So let me take these numbers for further analysis. And maybe now let's consider what kind of scenario should we consider for paddy co-firing. So we actually evaluated two most probable scenarios in our opinion. And just again, we considered all the amounts which will be given here will be addressing the Punjab state. So first scenario we can consider is that all available paddy residues should be co-fired, and what will be the necessary plant capacity to consume all this amount, and how many of such units should be necessary. That's one scenario, one option. And another option is that we can assume a pilot power plant, and we took this Harduangani. I'm not sure if I'm spelling the right name of this plant, but this is the one which we have received from our colleagues from the project team, this pilot plant information. And we try to consider this very pilot plant, and we then try to evaluate the result of, as a result, the amount of paddy which can be consumed only in this plant. So two, let's say, boundary scenarios. One, all paddy issued from Punjab, how many plants do we need? And another scenario, we have one plant and how much paddy we can consume. And in this scenario, and we call it, we will be referring to that as scenarios A and B. So this B scenario, actually, we can try somehow to give an answer to the question, if we can use this pilot plant to help to solve the problem of Delhi air pollution, which results from paddy burning, as we have learned that paddy burning is a very severe problem for the Indian cities, and also for Delhi. That's a big problem because it causes this air pollution. This photo we have found in the internet. So and to what extent we can use this very plant to solve the problem. So let's start from the first scenario. And the first scenario, again, we took this 15 million of tons. Then what fraction can be burned? This 50%, which gives 7.5 million of tons. The lower heating value of this biomass is it's around 15 megajoules per kilogram. That's also what
Mr. Żuwała, just a short comment. So this is mental exercise. We are taking Punjabi data and UP power plant. This is not a mistake. We just have data for Punjab and from this power plant, but it doesn't matter. We are just trying to show the problem, and I believe that the amount of paddy available in UP can be even bigger, and in Punjab there can be plenty of similar power plants. So this is mental exercise to show if one power plant can solve part of the problem of Punjab or Uttar Pradesh. Sorry for this comment, but somebody can be confused.
Mm-hmm. Yes, sure. That's just let's say that's just one of the case studies which we can consider. So one of the power plants, of course, we can select the other one or the group of plants, but that's just an, let's say, illustrative example. So these assumptions has been made. We estimated the power unit of 200 megawatt of electricity, the efficiency 35%, and we assume that the paddy straw energy share in co-firing around 5%. When we would like to recalculate it for the mass share, it's a little over 7%. Where we, of course, assumed the lower heating value of the coal, which is combusted at around 22. So roughly, energy share of 5% of paddy straw, it's something around 7.3% on the mass share. So we calculated the flow of the paddy straw, and then we assumed that the co-firing could be done by the 3 months of the some season, not a whole year, in this unit of a size 200 megawatts. And what was the result? Well, we would need 470 units of this 200 megawatts just to consume all this paddy straw from the Punjab state. That's a large number, but that's just to illustrate. And a visual comparison, maybe it would be, like you said, some mental exercise when we compare the size of a football diameter to the whole length of the football pitch. That's just the comparison, like a ball to the length of the football pitch. That's what we can consume comparing to the whole resource. So it's not the one plant is not solving the problem. So further on, we consumed only one biomass boiler, which takes 100% of biomass, and it's just another mental exercise. Yes, 100% biomass combusting boiler, and we co-fire this and we combust this biomass for the whole year. With the effective time 5,500, of course, we didn't assume that it will be all the year long, just 5,500 hours. The same capacity, 200 megawatt on the electric side, but the bigger efficiency, we assumed very roughly that the biomass boiler will have the bigger efficiency than the co-firing plant, not so much energy losses on the side of the co-firing extra equipment. So this paddy straw, again, we calculated in the range of tons, and again, the result was 10 units of such a scale. So it's for sure it's less than 470, but still it's not the perfect solution and the solution for all the problem. We will need 10 of such units. Just again, visual presentation, visual illustration, just 1 mug of water comparing to the 1 pitcher of water. So that's just the scale. It's bigger, but it's not enough. What we can try to think, basing on the Polish, let's say, exercises and the Polish experience, we can try to assume a little more biomass on the fields of Punjab state, around 20 million of tons. And we used some data which were valid for Poland. This is this 1/3 and another 1/3. And concerning to some Polish, let's say, farming and straw for energy examples, only 1/3 of the biomass from the field is actually collected, and only 1/3 of this collected biomass goes for energy generation. These are some rough assessments for which were valid for Poland. So it's just to give an estimation that when we want to be more close to reality, we should consider this really smaller amount of biomass which we can take from this 20 million tons. So it's a little more than 10%. It's 1/9 of 20, so it's 2.22 million of tons. And when we use all the time throughout the year as an effective time, 5,500 hours, and these 2 times 250 megawatt electric boiler. So something like this, this case study power plant, this Hadjugani plant. And we increase the energy share in the co-firing to 10%. So a recalculation to mass share, it's something like 14.6. So we are close to 15. That's an ambitious co-firing rate, but in our opinion, maybe reachable. So in this case, we need, let's say, something like a 12 units like that. So it's still not maybe wonderful solution, similar visual comparison. It's still one picture to the whole, let's say, big glass comparing to the picture. So it's still not the solution. We are coming closer, but it's not still the solution. And the paddy straw is still coming. So the new paddy is growing and all the time. So we are not going to solve the problem in 1 year, because if we burn some of the paddy for 1 season, we have the remaining, which goes for another season. And in this another season, we have the fresh paddy. So we drink the water, but there is still new and new and new water coming. So that's not something which could solve the problem. In our opinion, as we can see some light in the end of the tunnel, the reasonable and final destination maybe should seem a combination of co-firing of biomass and some 100% biomass units, and maybe some other available technologies. There are some. We want to touch them a little at the end of the 4th webinar. But anyway, simple co-firing should be the first step, in our opinion.
Mr. Żuwała, just to also clarify the picture. I understand that we are talking about, when we talk about co-firing, it's quite easy to imagine. It means that you put some biomass into existing coal boiler and somehow you mix the biomass with coal. But when you are talking about dedicated biomass systems, actually you don't have to think about stand-alone systems. It means that maybe we can also think about putting dedicated boiler to the existing coal power plant. So one block will be dedicated to biomass, and it can use also utilize the entire infrastructure of the power plant together with the air pollution measurement system. So it can be even, I would say, economically more beneficial than building standalone power plant.
Mm-hmm.
It was just clarification.
Yes. Yeah. So let's now maybe stop imagining the scenario A, when we took all this paddy from Punjab and we were trying to calculate how many boilers and how many plants we will require. Let's jump to scenario B, which should give us the answer: can we solve the problem using one Hadjugani plant? And we took this twice 250 megawatt electric. We again take this energy share in co-firing like 5%. Just to remind you, it's something like 7.3 on a mass basis. And we co-fire only 3 months. So something like a little over 2,000 effective hours. And we just try to find the situation on the map. So we can see the New Delhi here, and the Hadjugani thermal power station is marked with the red Google, let's say, mark. And then we try to assume that, well, that's also basing on the literature, because it was quite hard to find the, let's say, maybe the very reliable data from some, let's say, farming enterprises or farming associations. We based on some peer-reviewed scientific papers which give us the information about 0.16 ton of paddy straw could be taken for 1 kilometer per 1 square kilometer. That was that was the value which we found. So we used that value further on. So we using that number, we could draw 543 kilometers diameter circle around the Hajugani thermal power station, and we have this New Delhi somewhere in the middle of this circle. And then we also made some very small analysis of the windrows, so which means from which direction the wind blows in the winter, because we found that in winter season is different than in the summer season. So mostly in the winter, the wind blows from this direction, which is showed here with this blue arrows. And in the summer season, we have just the opposite, well, maybe not 100% opposite direction, but also quite a lot of wind blows from the let's say, east and south side. So and bringing the smoke to New Delhi. So we use these windrows just to check if the Hajugani thermal power station is somewhere in the middle and can be considered as a pilot. We found that's a good location. And to carry on the analysis, yeah, the paddy market should be analyzed, and that's how we can conclude. Actually, this is quite interesting in our opinion, because here we can use the power station of Hajugani not to consume all the available biomass. So we don't look at this power plant as a solution for all of the problem, but we can see that it's very probable that using only this power station and co-firing of 5% of energy basis, we could, in our words, quite effectively solve the problem in the circle of with the diameter of 543 kilometers. I'm not sure how much distance can a smoke travel, but in my opinion, this is quite a good distance, and we can actually, let's say, try to clean the air around the New Delhi using this Hajugani plant.
Mr. Żuwała, I have maybe it's impossible to answer this question right now, but from your picture, we can learn that in the winter, wind blows actually from Delhi to the power plant. So if the power plant generates this, or if actually that time the paddy is burned around the power plant, and in the Uttar Pradesh, wind blow up actually the pollution from Delhi to Agra. So can you comment it somehow, because it's just opposite than I was thinking about. I thought that the wind can blow during the winter time, blow the pollution from Agra to Delhi.
Well, we are not, let's say, the climate specialists in terms of the wind directions and from where the wind blows. But we based on some internet maps which show different cities and the windrows just around. So we found that for the New Delhi, the wind direction is like that, and it is just to show that maybe it will be effective to use this plant for solving the problem of 543 kilometers diameter circle. We will not solve the problem here, but we solve the problem here. In our opinion, that's an interesting issue, and maybe it should be somehow followed up further on, to use this plant just for co-firing, and maybe, well, we will not save all the provinces, but if we will save the capital and try to solve the problem in the capital, that would be good.